In this video, we're going to learn about Lewis dot diagrams. Specifically, we are going to learn how to draw Lewis dot diagrams for atoms. The first thing we have to address when we go about drawing Lewis dot diagrams is we have to determine how many valence electrons that each element has. The simplest way to keep track of these is to number the columns. This is column 1, column 2, and when we take the next big step, this whole region of elements is called the transition metals. We skip over them and move on to column 3, column 4, 5, 6, 7, and 8. Those are the columns. And those column numbers correspond to the number of valence electrons. So everything in this column has 1 valence electron. Everything in this column has 2 valence electrons. Everything in this column has 3. Everything in this column 4. Everything in this column 5. Everything in this column 6. Everything in this column 7. And everything in this column 8 valence electrons. So now we can go about drawing the Lewis dot diagrams. We'll quickly put the column numbers in here again for practice. And now we take the element hydrogen, and underneath each of the elements here, what I've put is a dotted box, because we want to imagine a square around each element. And we can imagine each side being divided in half, like so. So hydrogen has 1 valence electron. So we go to this drawing and we put 1 valence electron like that. And then we can transfer that to just the simple single symbol of hydrogen. Helium is sort of an odd duck. It's over here in column 8, but we know it has 2 protons and 2 electrons. And so it turns out that this first row starts out as an exception. Starts out as an exception in terms of the numbers of electrons it has. But we draw our 2 electrons together like this. And that is because we know that electrons like to form in pairs. And beyond pairs, they like to form into octets. And this is something called the Octet Rule. And these numbers can be seen if we count the elements in the row. So hydrogen's 1, helium's 2. And that reflects the number 2. And if we go to the next row, row 2, and we count those elements, we see that there are 8. And in the next row, there are 8. Thus, the octet rule corresponding to these 8 different elements, and as we know, as we increase the atomic number, we're adding a proton and an electron for a neutral element. So the octet rule corresponds to these 8s in the row. So, since helium can't go for an octet, it goes for a pair. So helium's Lewis dot structure looks like that. We see that hydrogen has 1 valence electron, and helium has 2 valence electrons. And we might say that its shell is full. And so for that reason, it has more things in common with the column 8 elements. So let's now move down to the next row of elements. We've got lithium, beryllium, and so forth. Well, lithium is in column 1. So that means it has 1 valence electron. So I can come down here and place this 1 like so, and that's it. That's all there is. So lithium is drawn like that. Beryllium has 2. So beryllium has 1, 2. We go to another side before we pair it up. Once we're beyond hydrogen and helium, we go to another side. So beryllium looks like this. Boron, over here, has 3. So 1, 2, 3. 1, 2, 3. Carbon has 4. So 1, 2, 3, 4. 1, 2, 3, 4. Nitrogen has 5. So nitrogen, 1, 2, 3, 4, 5. And now we see there's a pair. We call this kind of pair, we call it a lone pair. So when we draw our Lewis structure, we have those two, this side, and this side. Oxygen has 6 valence electrons. So we do the same process, starting from here, 1, 2, 3, 4, 5, 6. So we see there's a pair here and a pair here. So pair, pair, single, single. Fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. You see now there are 3 pairs. And neon has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. All 4 are paired up. All 4 sites. So this is how we draw the Lewis dot structure. It's another way of showing where the electrons are. And this will later help us figure out how and why different chemical compounds form. So when we see neon, notice all 8 are full. Just like hydrogen, its 2 was full. And this column of elements over here is called the noble gases. They are inert. They are unreactive, meaning they don't form compounds with other elements. And now we can see why when we look at the electron structure. They're full. And the same thing also applies to helium. Helium doesn't form compounds, and that's because its 2 pair is full. And so what we have in common are these chemical properties in column 8 that are about unreactivity, and that is caused by their shells being full. On our next page here, we have row 3. And again, I've given the same tools with the imaginary boxes and the dividing lines and so forth so we can have neat resolution on the pairs. What I would ask you to do is to pause the video and see if you can create the Lewis dot structures for sodium through argon, the row 3 elements. First thing we might do is to realize that sodium is in the 1 column, magnesium's in the 2, aluminum's in the 3, silicon's in the 4, silicon's in the 4 column, phosphorus is in the 5, sulfur's in the 6, chlorine's in the 7, and argon's in the 8. And we can, again, verify that by putting them up here, which may be a little easier to see, like so. So now we have sodium has 1. Magnesium has 2. Aluminum has 3. 1, 2, 3. Silicon has 4. 1, 2, 3, 4. Phosphorus has 5. 1, 2, 3, 4, 5. Sulfur 6. 1, 2, 3, 4, 5, 6. Chlorine 7. 1, 2, 3, 4, 5, 6, 7. And lastly, argon with 8. 1, 2, 3, 4, 5, 6, 7, 8. Now transferring these to the top, we have sodium over here with the 1 electron. So that comes up and forms that as its Lewis structure. Magnesium has 1 on this side and 1 on this side. Aluminum has 1 on 3 sides. Silicon has 1 on each of 4 sides. Phosphorus has a pair on the top, 1 on this side, 1 on this side, and 1 on that side. Sulfur, a pair, a single, a single. Chlorine, 3 pairs, 1, 2, 3, and a single. And argon, 4 pairs. And that is how we draw our Lewis dot structures. And these Lewis dot structures, as I said before, are a tool for helping us as we now get ready to start building molecules.